Hi, welcome to our annual series of short video reviews of our URTeC papers. I'm going to start with a paper that we co-authored with Diamondback Energy titled Geochemically Identifying Borehole Breakout Using Geochemical Fingerprinting, XRD and XRF Analysis on Oil Based Mud Cuttings. Now this paper describes a unique application of our workflow. Traditionally, our workflow has been used for optimizing development strategies by analyzing oil and water samples, looking at the zonal contribution in drainage rock volumes to help understand what's your draining interval, how to optimize cube development, assessing well communication to improve lateral spacing and understand parent-child relationships, and also understanding the source of produced water. This application is more for improving and optimizing your drilling program. So we wound up looking at some large cavings and identifying the origin of those cavings, updating the wellbore stability model, and then updating the landing zone, the mud weight window, and any casing points as needed. So we're going to look at a couple of case studies. The first one here, the operator encountered a significant amount of large cavings when landing in their target interval. The cavings were believed to have come from the curve due to the timing and some operational issues, and potentially indicated a failed intermediate casing point. So with about 600 feet TVD of open section, the idea was to use our GC by GC analysis to analyze the geochemical fingerprint from these cavings and correlate that to the nearby cuttings baseline to pinpoint the exact location of wellbore failure. Now, the first occurrence of the drilling issues made the cavings appear to be from the curve. However, once we analyzed the geochemical fingerprint, it clearly identified those cavings as coming from within the landing zone. So, on the upside, the intermediate casing point didn't need to be redesigned, and they were able to optimize the mud weight window of this formation B here in this region. The next case study, we looked at the first well in a new appraisal zone where drilling issues had been encountered, and the well had a lot of cavings, even though substantial work had gone into planning and an early wellbore stability model. In this case, approximately 350 feet TVD as well as a portion of the lateral were open at the time that this problem occurred. So the operator needed to understand if the intermediate casing design needed to be updated, or if it was the wellbore stability model in the lateral was potentially incorrect. In this case, we again used the GC by GC to fingerprint the extracts from these oil-based mud cavings and allocate that to a nearby baseline to pinpoint, again, the exact point of wellbore failure. After identifying that the landing zone was the source of these cavings, cuttings over this interval were sent off for XRD and XRF analysis to then update the mineral model. Ultimately, this new mineral model was successful. They changed the wellbore stability model, and future wells in this formation were a success. This method allowed the operator to pinpoint the issue as opposed to potentially having to address multiple issues, which would have been very costly and time intensive. And so ultimately this workflow saved them time and money, which is the ultimate goal. So I want to thank everyone over at Diamondback for allowing us to publish this, in particular Kane Nile and Corey Hamilton. If you have any further questions, please don't hesitate to reach out to any one of us. And then please go download and read that URTeC paper. Thank you.